when writing these in exponential form, remember what the base is. So this one doesn't have a base, so therefore you know that it's supposed to be base 10. Okay, this says what power of 10 gives you this? So you would write it out like this. What power of 10 gives you 3x plus 7? And for this right here, what is the power?
0.
It is 0.
So you have to equal.
Yeah, do you guys remember this? So you put a 0 right here?
Which one equals 1?
Okay. All right, now that is very similar to problems that you've done in the past, like this one right here. This would say, what power of 5 gives you 125? So you would write it in exponential form. What power of 5 gives you 125? And for this problem right here, what power of 5 would give you 125?
3.
It's 3. It's right there. It's right here. Okay? So we're doing the same thing right here. We're writing in exponential form, and then we solve it. Okay? Now, that's one way to think about it. And that's actually the way that should come natural to you since we've been working with reading logs. But there's another way. The way I like more. Okay, going back again to the lesson summary, lesson 15. You see this lesson summary right here? Tells us about the change of base ratio, blah, blah, blah. And all these properties of logs. Well, this one right here is the one I'm really interested in right now because you see what happens? You have a base b, and this log is in the exponent. And this log has the same base as the base it's being raised to.
They cancel.
And what happens?
They cancel.
It looks like they just cancel out and we're left with the x, right? So, what if I came at this problem like that? What if I just wanted to get rid of this log? What was that base in this log again?
10.
10. So if I raise both sides to the base 10, what should happen? Now when I raise it to the base 10, I'm not dividing, I'm not multiplying. That 10 is now the base for log base 10 of 3x plus 7. And the other side is 10 raised to the 0 power. That's what's happening. Now what happens to this based on the property we just looked at?
It cancels.
So now I have 3x plus 7 equals 10 raised to 0 power. I like doing this because it kind of follows the same line of thinking that you guys have been taught on how to solve an equation. Your job is to try to get x alone by using inverse operations. Like when you see plus, you do minus. When you see multiplication, you do division. Oh, by the way, what is 10 to the 1 power? I'm sorry, what is 10 to the 0 power? Yeah, 1. I hate doing that. Okay, so then I get 3x equals negative 6 because 1 minus 7 is negative 6. And now I do the inverse operation again, and I get negative 2. Now this right here is an inverse operation. This is an inverse operation. And when I rose both sides to the base 10, that was an inverse operation. So let's look at our next one. What would I raise both sides to the base of? Base 2. So now this is an exponent, and the 4 is an exponent. Now what happens to that log and that log base 2 and the 2? They cancel out, so I'm left with x plus 5. Oh, it's a beautiful thing. And what is 2 raised to the 4th power? 2 times 2 is 4 times 2 is 8 times 2 is 16. Alright, then I would subtract 5 from both sides. Oops. And that's my answer. You guys like? Alright, now for this next one, we got our first wrench in the mix. If you want to solve this, you have to have only one log. You have to rewrite it as a single logarithm. So you have to condense like what we did before. You guys ready for this action?
I'm ready.
Okay, calm down. Alright, we're going to go this guy times this guy. Log of x plus 2, x plus 5, and then equals 1. You guys see how I just condensed? I just multiplied what's inside, and I multiplied because we're adding the logs. Alright, so now I'm going to write up here. So I get log of x squared plus 7x plus 10. Don't punch him. Now remember, when you multiply this, you use distribution. Like you just go x times x, x times 5, 2 times x, 2 times 5. Or you guys can use the box method, the tabular method, whatever you want.
Tabular.
Okay, now I want to get rid of this log. So people,
10.
what base do I raise it to?
10.
Speak, Cheers.
10. Gotta let people think, dog.
You're on timeout now.
So I raise it to the base 10, and these guys cancel out because they're the same bases. And we get x squared plus 7x plus 10 equals, what's 10 raised to the 1 power? 10. Now, this is a quadratic. If you want to solve a quadratic, you have to factor. So, we got to make this equal 0. Right now it equals 10. How do I get rid of this 10 so that there's a 0 over here?
Minus 10.
Subtract the foo. So I subtract 10 from both sides, and I get x squared plus 7x equals 0. Now I can factor. I don't even have to use a big X or the reverse tabular method or anything like that. I just take out an X. Alright, now I get 2 answers. What answer do I get from that factor? X equals 0. And then if I set this factor equal to 0, what do I get? Negative 7. So your question here to find the answer, this is a reminder, you're trying to find out a number that you can plug into this factor that'll make it 0, and you're trying to find a number that you can plug into that factor to make it equal 0. And so look, it looks like these are my answers, doesn't it? Doesn't it?
Yeah, but extraneous solutions.
Oh, but we got extraneous solutions.
I forgot how.
Okay, I'm pretty sure this word is at the top of your page, but I'm going to write it right here because it's that important. Extraneous. Oh man, I hope I'm spelling it right. Can you guys check me? It's spelled wrong. Extra.
You're extra.
Extra.
Neos.
N.
E. O-U-S.
E-O-U-S. Oh, there's still an N?
Yes.
All right. Solutions.
Man, this isn't English, guys. It's okay.
Yeah, we still have to speak English. Okay, extraneous solutions. Okay, now extraneous solutions are these. Extraneous solutions are the ones, the answers that would give you a negative number inside of a log. So you can't have a negative number inside of a log. It's just impossible.
7.
It doesn't make sense. You know why? Because whatever's inside of the log, like this says a 10 right here. This says what power would equal x plus 2. Well, if I plug in 0 to this x right there, that would be a 2, right? And we're safe. We can raise 10 to a power to give me 2. But if I plug in negative 7 to this x, if I plug negative 7 to this,
It's going to give you a fraction.
it's going to give me a negative 5. Can you raise a 10 to a power to give you a negative number? The answer is no. Because if you raise 10 to the power of a negative number, that makes a fraction. It doesn't make a negative number. So, because this negative 7 will make a negative inside of the logs, he's extraneous. So we're going to cross him out. Extraneous solutions are no solutions. Okay, so extraneous solutions are the numbers that make the inside of a log negative.